All right, ladies and gentlemen, we are going to now start with the workshop, so I'm going to ask you to join us, to tone down the chatter a bit, and to get ready to learn about how all this agentic knowledge graph magic is done from the point of view of people who have been doing all of this incredible data engineering and AI engineering in the enterprises over the course of several decades, at least.
It is, sadly.
And with yeah, I can tone it down for a few years, only a few years.
It doesn't seem possible. I'm only actually 15.
Yes, yeah, he's the younger version of me, right? Exactly. But yeah, we already announced you folks yesterday, but maybe some folks are tuning in only today, so it's only fair that we introduce yourselves once again. But maybe I let you introduce yourself this time, and just, yeah, Charlie, you go ahead, you can start.
Sure. Charles Ivie, I'm a senior architect, senior graph architect in the Amazon Neptune team at AWS. I've been doing graph-based technology things for about 15 years and technology for a bit longer than that. And yeah, that's enough.
Awesome. Ben, you want to go ahead?
Ben Clinch. I've been working in and around architecture and data analysis for the last 26 years. And in some of the world's largest corporations, multinationals like HSBC, UBS, British Telecom Group, Citigroup, and a few others, and designing databases, and I'll tell you all about some of the things I learned along that journey as well, which hopefully are interesting and may even be controversial.
Awesome, awesome. Thank you, guys. And yeah, I'm the third one in this workshop. I'm Branimir, one of the founders of OriginTrail, and I've been building and working with you guys together for some time and really enjoying it. So, and thank you so much for joining us here today and sharing all the wisdom and knowledge with this crowd. I will let you guys speak in just one moment. A little bit of a, let's say, technical readiness for this workshop. It will be let's say slightly less engaging than the previous ones, which I think the folks here would appreciate, because I'm pretty sure there's a little bit of fatigue of just holding all the time. So there will be a lot of things shared, but you will also have a chance to do something. You'll have a chance to build a small visual graph and an ontology, if I'm not mistaken. And then we will be using that with something which the gentleman will introduce really well, which is actually the data product notion that you see in this title. And we will demonstrate how these data products can be utilized with the DKG, of course, since we're at DKGcon. And not just utilized, but ideally what we want to see and is an ability to monetize data products. So if you stick around to the end, which I hope you will, you get to see a couple of different things, and you have to play. You'll have an ability to play around with it yourself as well. So without further ado, gentlemen, I let you take over the stage, and I'll join you a bit later. I will be sitting right here. If you need anything, just nod at me very distinctly.
Fantastic. Thank you. Thank you, Bran. So yesterday we had a chance to talk about sort of mind shift, and had a fantastic chat with Professor Bob Metcalf afterwards about a mind shift is between mindsets. And we're going to sort of start from that perspective again, because I really truly believe that everything starts in the mind. So if we go on to just a little bit of a reminder, I'm sure people are familiar with this as an analogy, but actually the QWERTY layout that most of us are sitting in front of, and there might be a Slovenian version of it, but generally, even then, it's QWERTY, was invented in 1878 specifically to stop the mechanical arms in a typewriter from jamming. And the way that they creatively thought of stopping that from jamming was to create a terrible layout for your keys so that you had to type really slowly. Now, we are still using that blindly, irrespective of the device that we're on. In fact, some of our devices don't even have keys. If you've got a mobile phone, most of them don't. So, so we continue to use certain standards just because we've inherited them and they're familiar. And there have been many attempts to try and change those standards, and they haven't always succeeded. In the case of the QWERTY keyboard layout, familiarity has absolutely won, even though we know that it's quite a poor layout. So if we were to then apply that to actually some of the thinking that pervades IT, now this is where it gets controversial, because for many years I would design relational databases like this. And this is the Microsoft Northwind example database. And I'm afraid, I'm going to, SQL is everywhere. But actually, SQL is a design decision, not dissimilar to the QWERTY keyboard, that comes with some limitations. And we don't always see those limitations, like in the same way that fish don't necessarily recognize they're in water, because it's just around them, right? So I'm going to point out some of those limitations that I started to become painfully aware when I was designing these databases, and that SQL itself corrects. So first of all, if you were to look at the entities associated with this, seems pretty reasonable. You've got things like suppliers and products, orders and customers. That sounds fairly logical and fairly sort of standardized that you could put in other databases, but actually it's not, and I'll tell you why. A design decision has been made here that a supplier only links to products. So if you run a company that takes services from a supplier, that's not going to work for you. It also has a one-to-many relationship. Now, forgive me if you're not familiar with that terminology, but what that means is a supplier can supply multiple products. Sorry, apologies. A product can be supplied by multiple. Sorry. Let's
see, it's difficult, isn't it?
A supplier can supply multiple products, but a product cannot be supplied by multiple suppliers. So if you're running a supermarket and you want to buy your tangerines and oranges from more than one supplier, which is not a bad idea because sometimes suppliers run light on these things, that's not going to work for you unless you create a brand new product each time for each supplier that's also called tangerine, right? So that's a design decision that's baked into this. Now, inherently, those design decisions are what they are. But that means that this will only work in certain situations. So unfortunately, the lack of standards and the lack of structure associated with that means those design decisions mean that you're actually building a silo. And actually, each SQL database, by definition, is a siloed worldview, specifically for that application. And it causes big problems in terms of interoperability, one of the 3 I's that we care about so much from OriginTrail. In fact, interoperability is so poor in SQL databases, there's an entire industry called the integration industry that has come up around that. And if you read books by Dave McComb, he talks about what a disaster that's been for us as an IT industry. So if we then go on to the next one, which is, and again, a bit nerdy, but third normal form, which is the ability to be able to shape reality into a structure that works for SQL databases. And unfortunately, that means that we are shaping the way we view reality so it works for a computer. And really, ideally, you want a computer to be describing reality in a way that's intuitive to human beings, like mind maps or knowledge graphs, as we're going to come on to. So third normal form, if you have a customer here and you have a customer demographic, a customer can be in multiple demographics, and a demographic can have multiple customers. That's a many-to-many relationship. And SQL really struggles with this. So you end up with these made-up things that share foreign keys between both tables so that a many-to-many relationship can work. So you get this kind of customer-customer demo thing that isn't real in reality. It's an anachronism. It's a thing that's introduced specifically to make third normal form work. Now, we've worked our way around this for years as IT. I mean, I'm sure many people are familiar with this. But it causes all sorts of problems when it comes to AI. And it also causes problems when you want to try and do things with different databases that are different structures. So if we go on, thank you. The other thing is, when you design the database, the design is totally separate from what actually happens. So I'm going to show you an example of that later. We move on to the next. Every time you want to move from one version of this database to the next, you have to do all sorts of like dances and nonsense and take down the server, and it has to be over a weekend. And so you end up with database designers like I was back in 2008, where somebody's saying, well, look, Ben, we can't actually go live until we've got the database design perfect and it's not going to change again. And I go, right, so you know all the requirements for the foreseeable future, forever. I'll design that in. And so then they go, well, of course we don't. And I go, so how do you expect me to know? And then you'd end up with fudges, like people would go comment 1, comment 2, or free text things that people would then just shove nonsense into at the end of a table, just to try and create a little bit of flexibility, which ends up also confusing AI, right? So you end up with badly designed databases because it's rigid and inflexible, right? There's some grins going on, because I'm sure a lot of people have experienced this nonsense, right? So that means when you move across from one thing to another, it's actually really not portable. So lack of flexibility, lack of interoperability, lack of so many different aspects. Now, I still use SQL databases. I'm sure we all do. But what we don't always realize is the limitation it's imposing on us. So let's go on to the next thing. Exactly. So when I used to design a database, the first thing I'd do is understand the business. And I would say something like, an employee is paid with payroll records. And of course, when I was doing the design, that's what I would write in. So, no, sorry, if you go back. Apologies, I know we're going fast, but I want to go through this just to illustrate the point. Employee table here, primary key goes to a primary key here and a foreign key on the other. And so what this is effectively doing is taking my design that had verbs associated with it. Sorry, somebody's trying to call me, and they are going to go away. They take the design and remove the verbs from it and replace them with IDs. Now, if you're into knowledge graphs, you'll know that we care about those verbs, those relationships. In fact, we've actually stripped meaning from the data and the relationships in the thing called a relational database. Isn't that ironic? Where are the relationships? They're actually just implied by IDs, nothing more. So if we go onto why, so in fact, let's jump that one and come back to it. Sorry, 2 more, apologies. So this is controversial. In fact, actually, if you can do the animation, apologies, I should. There we go. Oh. Trying to describe an enterprise solely using a relational database is like trying to tell a story but not allowing any verbs. And that would be a terrible story. So this is Jane Austen, the famous author of Emma, and an AI version of Jane Austen looking really quite miffed, as we would say in the UK, on the basis that we've removed the verbs from her masterpiece. So why are we not all using this? And it is to do with familiarity. It's the entire IT industry has been broadly based around this. The conceptual, logical, physical model construct is entirely relational database thinking. You don't need those 3 layers. You need a physical one and you need a conceptual one if you're thinking in terms of knowledge graphs. And this is where we're coming on to why you have to do that. I love Upton Sinclair's crazy quote there, which is sadly true. People have made their money out of relational databases. Huge service integrators that I took a swipe at yesterday have made, well, billions off the inflexibility of SQL databases. It's not in their interest to actually move across to these things. But it is in our customers and in our interest. And really, the values of OriginTrail and the values of the community that you're building is about doing the right thing. And the right thing is actually changing the paradigm and not just persisting things that haven't worked for us across the world. So here are 2 of Charlie and my wonderful friends, Juan Cicada and Dean Alamain, who have been incredibly influential in the creation of knowledge graph knowledge. You know, Juan came up with R2RML and various other cool things, and Dean is the best-selling author of Semantic Web for the working ontologist, and they are incredible. They came up with these 2 benchmarks. Now, I'm not going to go through them in detail, but effectively, the links are here, and they're on archive, that demonstrated that just 10 minutes of semantic modeling around an insurance claims database that's stored in a relational database enables you to be able to get 400% more accurate results from an LLM, an agent that you're asking about the quantitative results against a relational database. I do a longer talk, which we won't be doing today, about talk you through that, but we will jump to the results. So again, I'm always into spoilers here. But the spoilers were there were a number of different questions organized by different quadrants. Lower question complexity here, so just things like do some counts of things. Other things like do some aggregates. And then high schema complexity was more than 6 tables, SQL relational tables that it would have to reference. The experiments were organized in this way, but the first column in each experiment is just the control, where you ask an LLM a question about a relational database without any Sparkle or SQL in between. The other two, you can see. What this shows is that for their benchmark, it's released and repeatable. Anyone can do it. It was wrong 100% of the time with more than 6 tables, even for the simplest of questions, because it's missing the verbs, right? That's one of the, it's missing the context. And most importantly, it also always gave you an answer that was always wrong. Now, if you had an employee or a colleague like that every time you ask them a question, they'd always give you an answer because they're incapable of saying, I don't know, but it was always wrong, you really wouldn't trust them, would you? You know, like, when's my flight back to the UK? Oh, it's on Sunday. Great, Sunday rolls along, I've missed it, it's tomorrow. So, okay, this is why graph matters, and this is why we're pushing it at every level. Now, of course, this is our homage to the legends that are Branimir and co. And in fact, I might add, I use it a lot, but I always say OriginTrail, the trusted internet for AI, just because I do believe in fairness. So, one of the things that we were talking about was the ability to be able to build up the logic and reasoning and facts-based things. So we're going to zoom through this really quickly. But effectively, if you've got a relational database that we're going to come on to, you can actually map these quite simply using effectively the principles between R2 and RML. So if we go through the animation, first of all, every table becomes a class. So if you click again, that's been truncated, but vehicles up here and offers here. So those are classes that you would include in a knowledge graph. Every row becomes a node in those classes. The primary IDs of each table can be used to mint node URIs as a default. The foreign keys, which is, of course, the primary key of another table that's being used as a reference on another one, becomes effectively the edges to other nodes. And then finally, these things become attributes, or as we would call scalar values, within the graph. So actually, you can, of course, with many-to-many and all the other nonsense that's in there, you do have to do a little bit of massaging, but actually, these principles can be applied very quickly. So, do you want to cover DPROD?
No, you can.
Okay. So, do you want to, Charlie? Or?
No, you go.
Yeah. Okay, super.
You're in a good
you're
flow,
you're going to show the awesomeness of this graph.
Yeah.
Okay. So, mindful that we don't want to take too long, but DPROD is a metadata standard that you can put onto your nodes within the DKG, but also is being widely adopted by many organizations, specifically to include interoperable metadata between data products. Now, data products and data mesh is a fantastic pattern, but it's failed in many organizations because, strangely enough, people haven't treated them as products, despite the name, and they haven't treated them as interoperable because they haven't used interoperable metadata. So it's not a failure of the concept, it's a failure of the implementation of that concept. And DPROD actually helps people address that. It is based, like so much of the best things in the world, the learnings of many, many brilliant experts in W3C and the open standards, but it's been tailored in such a way that it's very easy to be able to adopt. So you have the concepts of data products, and I won't take you through all of this because it's beautifully documented on the link that we will be including. But you have things like, for example, has policy, so you can describe policies in ODRL against the data product. It's made available as data services with different types of distribution that might be in different serialization and formats. And of course, it references data sets that make them up, but also has outputs associated with data sets. So as a result, this is a really powerful construct of metadata to make it interoperable. And here is some of the DPROD standard applied to what we're going to be showing you as part of the demo, the kind of interactive workshop that we've got coming up. And with that,
Sure.
Any questions? And then we can go on to...
Yeah, fine. So, hands up who understands or knows what a data product is, first of all.
Ooh.
So we have a,
So not many.
few. Okay.
Good
Well, you could think of a data product like... think of it like a boundary to something you could potentially buy. It doesn't mean that they're always for sale. Sometimes they're free. But the point is, if you go into a shop and you see a product, it has a name, it has a description, and it has a way of getting it, such as it's on a shelf, right? It's been distributed to there. So really, just think of an amount of data which is kept in a sort of kind of isolation that you could purchase or acquire in some manner. The DPROD standard gives us an ontology that standardizes the model of that. So much like MCP describes the interface into a language model, DPROD will give you a standardized definition of an interface into a data product. In many ways, you could see a DKG node as exactly that sort of thing. You know, it's an entry point into something which you have a measure of control over. So we're going to be looking at we're going to build a graph today, and you may have noticed there were some tables, some SQL tables, and we were saying, well, you just have to turn this into a node and that into an edge and whatever. It's so easy, you know. But actually, when you see it, if you haven't been used to doing it, that's still a bit of a painful task. So we're going to be using some ridiculously easy tooling to do that today, and you can all do this. And we hope that everybody can do this, even if you've got literally zero programming experience whatsoever. So we're going to be using completely no-code solution to build a graph from an existing data set. In fact, from two data sets. Those two data sets being a car dealership and the Department of Motor Vehicles. So if you can imagine, there are two data sets that together give us more information. The car dealership, we're going to ask as many of you as would like to become car dealers for the day. So we're here to teach you a new way of working. And each of you will be given a lot of cars, which you can sell, and that will be your data product, effectively. So each of you will be able to sell, I think it's like something like 10 cars. They're not real. So unfortunately, you can't take any benefit from that. But and then there will be information from the Department of Motor Vehicles about those products, some of which will prove some of the data in the car dealership to be possibly false or of bad origin, shall we say. But only with the DMV data products available to us can we tell that their mileage is authentic, that sort of stuff. So we're looking out for all you dodgy car dealers out there. And of course, it wouldn't be correct if we couldn't.
Yeah, perhaps I can pitch in if the
Go
sound
for
is up. So we will be dealing with a lot of these cars, and the two data products will be basically implemented as two nodes on the DKG. So that's kind of what this hacky slide tries to say. But ultimately, the two data products will communicate through the DKG. They will share some information exactly on the mileage. So we have exactly that example. And you'll be able to see that a certain car's mileage has been brought down. So I think I messed up the order.
No. This is good.
No, you're good.
There's a QR code
Oh,
for people that they need to scan.
Let's
So
re-
we'll
what
go
have I
back
done
to
now,
the
Ben?
presentation.
This is your machine.
Here we go. Let's do
Yeah,
it.
so maybe I can quickly explain while we get there.
Oh, yeah, we went past it somehow.
Yeah, maybe I don't know. Maybe I messed it up somehow. Anyways, so now is the time to get in action, and the idea here is that basically you scan this code, and if you can, that would be useful to throw it on your computer. But basically what you need is a couple of links and some usernames and passwords there. If I'm on your way, I'm sorry. I hope this works. If it's convenient enough,
Okay.
but anyhow, so what you will see, and maybe we can share the spreadsheet as
We
well.
will, we will indeed. Has everybody got the QR code that wants to have some fun with this? It's very, very easy, and deliberately so, because we believe that it's been made too complicated for far too long. So, okay, hopefully everybody's got that. We can...
I don't know what I'm doing on this.
Here we go. This is like me on the Mac earlier.
It's a bit like I'm being a bit like my dad using the internet at the moment.
So if you were lucky to scan it, you should be opening this, and in this table there's a couple of information you need. You should input your name.
You put your name in here, so you've claimed that user.
Yes. So we don't clash with each other because not all users are the same, as you can see. So you're going to be logging into separate instances, if I'm correct.
Oh, no.
Really? Okay.
I think Bran's the owner. He might need to just
apologies.
change the setting.
I'll do it.
Anyone who has the link.
Thank you
access,
for
no
that. Everybody is a commenter. Okay. Now you guys are editors. So
Great.
maybe just have to
Who will be the first to edit it?
Yeah, that's the point. We should be able to see it live.
Yes.
Wow.
And yeah, basically, we're going to start with Graph.Build. So that's the very cool part. You'll be building actually graphs with it. So once you claim the names, we'll guide you through this, but there's two places you're going to go. So we're going to use Graph.Build, and then we're going to go into one, actually, DKG node. We're going to be the dealership. So what we're doing here is we're building up the data product of the dealership, and we assume that there's a DMV data product somewhere. We set it up on another node, and this node of ours that we log into, but not yet, don't go here just yet, it's too early, is going to be able to pick up some information from the DMV data product. Yeah. And for some reason, we made it, because of course we want to make it exciting. There it is.
Right, Branimir.
Yes.
We have a winner.
He wins.
Legend.
First, the beer goes to Branimir. Yeah, so we're gonna. So in this world of ours today, in this workshop, DMV data is not free, so you have to pay to query it, and we'll explain more on that later. So, but anyhow, please jump in.
So
a few names.
If we were just to point out something very important, which is that if you get beyond user 15, you might see that it changes color here because they are actually different servers, just to make sure we don't run out of server capacity. So user 15. Well, user 16 onwards to 32, you need to sort of scroll along to column E and click on the link for your particular user, just so that you make sure you can log in. If you can't log in, that's likely the cause.
Likely the cause, yeah. So basically, you're going to column E for your user that you've claimed and logging in with your username and password. And I think once we get a sort of critical mass,
yes, let's do
another 4 or 5 at least of you willing participants, hopefully.
I love it. Some people are on iPads as well and phones, so it'll be really exciting to test that as well.
All right.
How are we doing? Any more? Oh.
Okay. It looks like there's 10 people logged in total, so I think maybe there's just a few. There's a few coming in now. Okay.
Nick.
All right. Okay. Should we move on?
Okay, should we move back to Graph.Build? Yeah. Let's do this. Do you want to talk people through it?
Yeah, I'll talk people through this. So we're going to be using Graph.Build. Graph.Build is available on, you'll see it on the Amazon Neptune documentation. It's third-party tooling, so it's available on the AWS Marketplace. So anybody could use Graph.Build with the Neptune cluster, with any other, in fact, with any other graph database too. But certainly if you spin it up in CloudFormation with Amazon Neptune, it's incredibly straightforward to get going. We've already obviously deployed these services for you to use and a bunch of users. And once you log into the service, you'll see something akin to the following page. Now, In Graph.Build, you can design ontologies, so you can design the logical models for your graphs without a single line of code. And then you can also actually bind physical models to them from where they exist already. So where we saw some SQL database tables before, we can point at those with a newly created ontology and build a graph. So actually, building a graph is ridiculously easy. We've created a couple of ontologies here. In fact, and these, you're welcome to create a new one here and mess around and try to create ontologies yourself. But here's one we made earlier, or in fact, here's two. One of them is for the data from the Department of Motor Vehicles. And the way that you create create ontologies in Graph.Build is you grab one of these input things here and put it in. Now, a class is like
Charlie,
a concept. Yeah.
I'm sorry to interrupt you, but I'm having trouble logging into servers. Just checking.
Yeah.
Is everybody else? Yeah. So what happened?
Ah.
For some reason,
Have a look.
it doesn't. It like gives us this HTTPS issue. So maybe a good moment to give people like a few minutes to log in and
Okay.
so they can follow. Because I'm not able to follow, and
Is anybody logged in?
yeah.
Okay, we have some.
So the thing is, inside the cell you have a link which doesn't, you're unable to access it, but you need to copy the text from the cell and open that link. That's the
Okay.
thing.
I wonder
It
if
points to a wrong URL, but just copy the text from the cell and you're.
Oh,
gonna
you're
be able
kidding.
to
The
access-
link actually points to the wrong place.
Yeah,
That's
unfortunately.
hilarious. I love that one.
that's
Okay.
not the first time we've had that problem with Google Docs as well. So that's an interesting.
Yeah, okay.
In,
So well done.
Yeah,
Some of you
thank
overcame
you.
our deliberate test.
yes. Google Docs does seem to do this.
Yeah.
So no, that's cool. Okay, thank you.
Okay, so just to be clear over the microphone, the link must be copied and pasted, not clicked, as you would have
This is how we hope to demonstrate that Graph.Build is easier to use than Google Docs.
Yes.
Maybe we can even.
So maybe we could have a show of hands and see who is now actually on
Logged
the homepage or logged in.
Who managed to log
Okay,
in?
logged
Oh, good. Lots more.
Okay, that's
hands.
enough.
Okay.
That's enough.
Okay.
All right, great. So, once you're logged in, if you click on the logo, you'll see something akin to the screen in front of you, where you'll see two ontologies that we've previously created. That is the logical models. So here we have the ability to draw by dragging in classes and properties, things that we want to create. So I could, in here, for example, create something called, I don't know, a person, simply by typing it in and doing it. And that's me creating an ontology. So behind here, there is the code that you could use for your generative AI models to actually prompt for stuff that you want to do with large language models with no code, which is great. And if you want to add properties to things, then you can do so by just dragging in something called a literal. We don't really need to worry about any of the complexities of the advanced features, because a lot of the time you don't need to use them. But you can choose the data type of the thing that you want to give a property of, such as a name or an age of a person or anything like that. And then once you're happy with the data type you've chosen, which is a string, I could drag something like that to there, say that is a name, and there I have created a bit more of an extension to this ontology. Now, that's the DMV ontology. I'll get rid of this stuff which I created here, which I don't need. I'll go back to the other ontologies which are here, and you'll see there is also a complete ontology there, because one was supposed to represent just the DMV data. This one represents the data from both sources, and we're going to bind both together. So you can see a bit more of a, which is now, okay, so somebody else is looking at this, which means I am only a read-only user now, which is fine.
By the way. If you're using two, that's not a problem.
Which is absolutely fine. So here you can mess around with building ontologies, but we've done this just for demonstration purposes, to show you how logical and, quite frankly, drawing a mind mappy it is. But that's great. So you've designed the model that you want to use for Gen AI. You've designed the shape of the data that you think makes sense to your organization to answer the questions you want to answer. But you need to get the actual data from somewhere. And in Graph.Build, you can do it in one of two ways. You can use semi-structured models, such as a stream of JSON, XML, CSV, that sort of thing. or you can pull from existing data sources, and that's what we're going to do today. We are going to pull some data from an existing SQL database which contains information about all of the different individual dealers' cars. So each of you will be a different user, and I'll show you how to do that in a moment. So, quick show of hands of who's up to speed with what I'm saying so far. Oh, that's even more than before. Brilliant. So, if we open up this model here, you'll go in, and in fact, you will probably be a read-only user of this particular model, I think. But the point is, you need to do what it says in the name, which is drop down from the drop-down button at the top, and then save this as something else. Just there. And you could call it whatever you like.
We're suggesting username just so it's easy for you to find it again.
Mine.
At your discretion.
Mine. All mine. And once you do that, that means you've created a copy, an exact copy of the other model. And this is essentially a mapping model. So this is how we're going to build the real data to match to our ontology. Now, on the left-hand side, and it's not complete. On the left-hand side, I'll run through some bits you can see. We're not going to touch functions, but there are advanced transformation features you can do. So wherever the data's coming from, whatever it is, if it's messy, if it's wrong, whatever, you can fix stuff. Different sources, you could point to multiple databases if you want. IRI config, more advanced semantic web stuff that we're trying to obfuscate to make it easy for today, but very powerful stuff you can get into. Quickly, just on the source, you can see the database that we're connected to. It doesn't really matter what that is for this. Going back to the input tab, here is where we can write a SQL query to get data, which we're going to turn into the graph. So, okay, fine. Maybe I was a bit wobbly with the truth. There is maybe possibly a tiny bit of code, but it's the SQL query, so I don't even know if it qualifies, to be honest.
Doesn't it default to select star anyway?
I think it defaults to select star from synthetic data vehicle, but I think if you execute that query, you will find that you get nothing. Is that right? Yeah, you get nothing. And the reason you get nothing is because we deliberately put lot number equals 9, because, not because I'm some sort of 80s dance track, but because there's no user 999999. Now, if you replace that with your user ID 1 to 40, whatever it is, whatever number it is, and execute that. So which one are we? Can you remember, Ben?
We do 32.
We'll do 32 because I don't think we're going to get that high.
I think that was at the end of it all. If I don't know.
So just the number, right?
So
Okay.
just put the number in. That means we're filtering by your user, basically. So that's your lot. So this is your car lot, the cars that you're going to sell. That's the idea. So execute that query, and you will see further down, you'll see all the results, and that's great. But that's not actually what we're interested in. Seeing the results is nice. It gives you validation of what you're going to make, what you're going to build. But we're really interested in the input blocks, because that is the column headers of the tabular response that comes back from your SQL query, which we're going to be able to use
and brand
to build
somewhere there, I think.
What's the what?
Brand is somewhere down there. Brand name. There we go.
Brand. Ah, yeah, that's the missing one, isn't it?
Yes.
Okay, so we're going to use one of these elements to build part of our graph. So I can drag this in. You'll see that I've already bound a load of stuff, but we'll see how to do it yourself. So if you drag in the brand name from here, you'll be asked whether or not you would like to create a node or a property using that brand name as the unique identifier. So you've seen lots of URIs flying around as a concept. People keep talking about using URIs as IDs. Well, again, you don't need to worry about how that's constructed here. You can just say that I want the brand name to be identifying a brand. So I can say here that this is a node, and it's going to use the brand name for the key in the top there, and I can choose from the list of classes available to me what kind of thing this is going to make in my graph, which is, of course, a brand. So, again, incredibly straightforward.
It's almost weirdly simple, right?
It's the best things are. And so there we go. So now we've got our brand. I can't remember if there are any properties to add to a brand. Can you?
No, I think we kept
I
it
think
super
that's it.
simple.
All right, kept it super simple. So that now it's like, okay, well, how do these things all relate to one another? Because there's lots of missing links here which exist in the new ontology. But because we built an ontology, and because the system knows about an ontology, it will know about the relationships between these things, and it will. Is that right?
No, it's it will
fail completely on that particular example.
If you go click drag from vehicle to model, I think.
Ah, sorry, I've done it the wrong way around. Yeah. So if I drag this link down from there, then you will see that there is actually many. Okay, so what is that? Model.
Can I maybe interrupt you just for
Yeah.
a sanity check?
Please.
How many of us have managed to follow? Because I didn't. How many of us have managed to follow? Okay, not too many.
Oh yeah. Okay. So let's go
We're a
back.
bit
follow.
fast. We're a bit
With the
fast.
brand, were you able
Let's
to find
go.
brand name on that?
That's so. I
We're working backwards.
can we go from executing the query again, please?
We
I'm
certainly
there.
Certainly.
Yeah.
So I executed for my
No worries.
ID, which is 8.
Yeah. And
And-
did you get results underneath?
Yes. And what
Good.
should I do next? I'm sorry, I got.
Not
no,
a
that's
problem
all right.
at all.
That's
Not a problem at all. So, so you got your results, and then below that you'll see that there's a load of input blocks,
Okay.
and those are representing the column headers of the result of the SQL
SQL
query.
query, right? Okay.
And we're going to use that to bind to our new graph, to our new ontology.
Got it.
Okay.
Sorry, I think there's just tiny distractions, and you lose one thing, and
I
then
totally
you
understand.
Oh, yeah,
the whole
absolutely.
train. So
No,
Yeah,
it's
if
good
you-
that you said that.
That's what we're here to do, and actually we're on good time, so I think we're fine.
yeah,
Plenty of time.
Yeah.
we're great on time. So
All right. So everybody else has now that Brand's caught up with the rest of us. Is there anyone else? Oh no. Okay. Cool.
Okay, so and you found brand name at the bottom of the list. Is that? Can you see that there?
Have people found brand name at the bottom of the list?
Good. Okay.
Yes.
Excellent.
Okay. So we can drag in the brand name. We can call it a node, and we can select that it is of type brand. Okay.
So if you were to drag, I think brand to model as the next example.
So now we're going
Has
to
everybody
connect all
got
the
brand.
dots.
Have you dragged brand in and made it a purple node? Yep. Great. Okay. Oh, for some reason it's defaulting to offer ID. This is odd.
Yes.
Okay.
Okay. I think I know why, but we're not going to have time to fix that now. So, in another example, this would actually populate this
yeah.
with exactly the right
Actually,
thing.
that's because I did it the wrong way around. It is manifest.
Yeah,
by,
yeah.
isn't it? There we go.
But I think if we were to do this, yeah, here we go.
Ah.
That's it.
Okay.
So I'd like to ask you all to do a little bit of a configuration change if it pops up like this for you. In fact, I don't think it will. I think I possibly... Yes, it will, because you've all created a new one. If you could all go to IRI config at the top, we set a bit of configuration wrong. And underneath, you will see a limit model to ontology switch. I'd like that to be on, please.
And while you're doing that, let's explain what that does, because what that means is we've designed an ontology, we've designed a shape of how the data really should conform. And we can use it as a guide only, where that's not ticked, or we can actually conform. Every time you move the data into it, it must comply with that structure, which is my favored approach, and of which now you've set that thing to ticked, it will now follow faithfully the design of your ontology, if that makes sense.
Thank you, Ben. So now it will definitely work, because demos always work really well like this, don't they? If I drag
It might be the
model
other way
to
around.
brand,
No, it's the other way around, though. Actually, try and do it and see if it fails, because it should fail, shouldn't it? No? It does fail. Good.
okay.
Okay.
Manufacturer. I don't know where offer ID is coming from, but there we go. Never mind.
But so now, if you delete that, and no, model is manufactured by a brand. There we go. That's
Yeah,
good.
that's fine.
So then, vehicle to model.
So then if we drag vehicle to model, I think we're always going to get an option for an offer ID for some reason. Or maybe somebody is... Okay.
Okay.
I would like you to make another change to the config. I would like you to not limit your model to the ontology. Because this is my preferred way of
Oh
working.
dear, okay.
No, it's actually not. I'll just make it. And now we can put in what we want. Yeah, so, I mean, to be fair, it's very intuitive anyway, but if we'd have... I think what's happened is somebody or one of us has edited the ontology while we were setting this up or something, so it's not binding it. But the idea is you set the ontology, and then these... When I drag this from here to here, it will know what the link is, so it will just drop it in. You won't have to choose. But you can unrestrict yourself and choose what you like. Yes, there's a question, please.
Just a sec. Microphone coming your way, so people can hear you online.
Thank you very much. I just wanted to ask, maybe it is model-specific, case-specific.
Well, we're not actually typing anything.
Uh-huh. Okay.
So even though we're still choosing from a list. You can type anything in as well, because this is now unrestricted. So we'll choose from a list of all the available options and choose one, or be able to type something in. But if you're choosing something, then it's bound to be in the ontology. So that's what we do now. But generally speaking, though, as a rule, you're right. Everything is case sensitive. So we can join a vehicle to a model using the edge model. We can join a model to the brand using the edge manufactured by. And we can join an offer to a lot using...
Grouped by, isn't it, or something?
Grouped
organized
by, is it?
Organized by, there we go.
Using organized by, okay. And then once we apply that, we've completed our graph model.
Question.
Yes, question, please, Branimir.
So when I did this organized by just now, and
Yes.
I'm going to do it again, the pop-up, maybe you can also do it just so people can see it.
Yep.
There's a... So there is the organized by thing, but there's something on the left which says KGC.
Yes,
Can you
okay.
explain what it is?
I can explain exactly what that is. I was
done.
trying not to because I thought I was trying to keep it as simple as possible. But we spoke a little bit earlier about prefixes. Some people describe prefixes. Prefixes are there so we don't have to write fully formed URIs all over the place because they look horrible, they take up a lot of space, and it's unnecessary. Because we, generally speaking, in ontologies, we use prefixes heavily repeatedly. We like to have a very small number of prefixes, so it's easy to manage the data set. So we have 2 prefixes we're using in this data set to use a shortened version, KGCV, of https://ortecha.ai/kgvehicle/.
Which you don't want to say too many times.
Which you don't want to say too many times.
Oh, and schema.org, of course, that Bran mentioned earlier. And one of the great things is you can bring in any ontology to be able to reference, which, of course, is extremely powerful.
Yeah, thank you. I don't know how to talk about that. Yeah, you're absolutely right. So we designed our own ontology, but there are, of course, all the public ones. Just import them, and you can use them. So schema.org is already there and all that. So now you know, even though you are not an ontologist, how to design an ontology and how to build a model. But there's more to do. So this is organized by. So hands up, please, who's got here? Oh, good. Thank you. Bran? Yeah? Okay. Right, so now we've done that, we can do a number of things in Graph.Build. The first thing we're going to do is generate model. And we can generate and test this, and the result from that is not particularly visually stimulating, I would say, but it does give you some raw RDF here that you can use. So that has generated actual RDF. Now, in a production system, this would already be bound to BlazeGraph or Neptune so that you could write straight there. For the decentralized knowledge graph, this is essentially giving you this could be giving you a large part of your asset, your knowledge asset, if I'm right in saying. This is effectively would be your knowledge asset. Now you can download that, and it will download it in a fully standardized RDF format, completely compatible with the W3C standards. As I say, in a production system, this would go straight through. I think that's pretty much all we have to do here today. The only thing that we'll have, the other thing that we can do here is publish the model. In publishing this model, what we're really saying is we're baking in this job to be a production job. So,
do you want to mention this as well?
Virtualize. Okay, we'll talk about that. Yeah, so there's a virtualize button here as well. We won't need to use that, but that gives us the ability to draw data in real time from the SQL database underneath.
without having to move it
Without having to move it, yeah.
preemptively.
So you have options there. You can have a virtual endpoint for your knowledge graph or a materialized one where you actually move the data into another graph. Yeah, and I think that's pretty much all we need to show of Graph.Build right now. Yeah. So
this is what you need to be able to break out of SQL thinking and a brave new world of interoperability. And one of the things, as somebody, I'm still relatively new to the graph community, would you say, Charlie, considering,
sure.
you know, and a lot of people sort of come up through SQL using Ortecha and other really powerful tools, but they're really hard to get started on. And there's a really steep learning curve. And to me, that seems like a real shame, because actually the domain knowledge that people hold within the business analysts, within data analysts, within anybody who's an expert in what they do, if they can draw a mind map, they should be able to communicate using the correct tools. And what I love about this as a tool that we use with a lot of our clients, and that I use personally on a daily basis, is the ability to be able to map out very rapidly concepts that are much more intuitive, that I can put in front of a business person or somebody unfamiliar with technology, and they'll go, yeah, that looks right, that bit doesn't look so right. And I couldn't do that with those entity relationship diagrams I was doing back in 2008, because they'd just look at me blankly and go, no idea what that means. And what's all this crow's feet thing and all of that stuff? Whereas actually, you know, if we were to hide even the attributes, it's 6 things. Like there's a brand that let's say a vehicle has a model that's described as a model name with some attributes associated with that model, and that's sold by organized by a brand or manufactured by a brand. It's marketed as an offer that will have of course. The reason why you model that slightly separately is because there'll be many offers in the lifetime of a vehicle. And you know, maybe it won't sell at the original offer price as well. So even before it's sold, it might change. So you want to be able to track that kind of thing. You can organize them into groups or lots, like you would have at an auction, for example. And you can buy lots of vehicles from auctions, and so on and so forth. This, you know, you don't have to be a vehicle expert, but if, you know, this seems highly intuitive, and that accessibility, you know, we were talking about inclusivity as well as the interoperability. This all reinforces the core values of what the OriginTrail and DKG community is after, which is, you know, to make this easy and for people to be able to utilize this for the betterment of themselves and their organizations and society in general.
Just one more thing I'd like to add about the features here. You're not restricted to basically anything in this platform. If you want to build a property graph, because that's going to suit your workload, one graph initiative way of thinking, you can do so. But you can still use the power of the semantic web and semantic modeling to do it. That's great. And also, if you want to, you're not really going to create your whole data landscape for your graph in 1 or 2 diagrams, because they'll get huge, potentially. You know, they might be quite big graphs. So really, in real production use cases, there'll be lots of diagrams, and they all work together. So I could take this and create a new diagram, and I could use one that already exists as part of the next. So there's an inheritance in the designs and the models too. So I could take that, go forward, say I wanted to take a semantic graph. Do you know what? If I wanted to build a property graph from this point, I could do that as well, even though the original one was semantic. I can say which ontologies I want to use within this ontology. So you can build up basically a network of dependency ontologies and focus on things in isolation.
So to bring that to life, if you maybe, you know, we've got a piano on stage. Maybe there's a company that sells musical instruments. Somebody has modeled all the products and the different sort of aspects associated with those products, and then the sales team, they don't want to have to reinvent the concept of a product at all. So you've got a category, or a domain as we'd call it, of products, and then the sales team go, well, we've made these many sales of these different products. So they actually bring in the concepts into their data product, so to speak. referencing somebody else's model. So they don't have to reinvent the wheel each time. And of course, every time somebody's trying to reinvent the wheel, there's a risk it's incompatible with the other wheels. Yeah. So that's why that ability to be able to do exactly what Charlie's just shown scales so beautifully across organizations and between organizations around standards like GS1 and schema.org and other great things.
Yeah, so here I've thought, okay, I think we're going to have to put in some more information about vehicles. Maybe there's some telemetry, statistics or something. Well, that could be this particular diagram, and I'll pull in the vehicle from my other model, so that already inherits all of its properties and everything like that. So I don't need to do all that again, and we can start building our new graph from there in whatever way we want to. So, yeah. I think that's pretty much the end of the Graph.Build bit.
And then over to the...
Okay, so moving on, now we're going to go into the OriginTrail bit. So I need like a moment to set up just so we can switch it
Yeah, no worries. So thank you very much for listening to us for the section 1.
Thank you.
Hey, thank you. Oh, and the gentleman will still be part of the workshop. It's just, I guess I'm going to be speaking a little bit more. Are there any questions, by the way?
Oh, yeah.
It's a good moment for questions while I set up.
Good.
Yes. Okay.
Over to you,
Pass
Steve.
the mics, please. Who's the mic person?
Hello. Okay.
Hello.
So can we use this graph for, or how can we use it for like a RAG for a chatbot?
Yeah, that's a very good question. In fact, there are applications which demonstrate exactly this, which Ortecha are running at the moment.
Yes, actually, maybe, I mean, I don't know, we may have time even today to do it, but if not, I mean, let's connect on LinkedIn and we can do like a live webinar or something and show you that. So it is one of the, you know, Dean Alamein and Juan Cicada we were talking about earlier, and their white papers, we can share that as well. But effectively, we've recreated that by creating a graph database, and actually, you're going to, and that you can then run an LLM against, and actually, their benchmark is deliberately very basic. You can get much more accurate results, as you know. And actually, we're going to see, even with the OriginTrail thing that we're doing today associated with those data products, a form of agentic AI using Neuro Symbolic. And you know, that's, to be honest, that's, in my, you know, that was the best way of doing it. But we do have various different demonstrations of ways that you can do it in a very simple way. But I guess what my preferred way would be to do it on the decentralized knowledge graph.
Yeah, maybe we will get to show it. I don't know, in a little bit. Maybe we could.
Like
essentially, you have got the building blocks there. Yeah, so what we've shown you is the building blocks exactly for that. So, all right, any other questions?
Great question.
Yes.
Hi, hello.
Hello.
So would you say that it is almost always worth the effort to convert the SQL database into the knowledge graph? Or are there some cases where there would be more to consider?
Sure. Absolutely. So you could, as we mentioned before, you can virtualize graphs or you can materialize them. You might want to leave the data where it is and query it as is, but you still want your ontological model as a layer on top to be able to speak to it in honest and correct, more
absolutely,
terms.
because you get that much more accurate response. And also, I mean, you can use labeled property graphs. I am slightly obsessed with RDF, like I think many people here would be, because of that interoperability point that I made at the beginning. Now, labeled property graphs, and I'm probably going to cause problems for anybody watching this, but labeled property graphs are incredibly good at doing graph analytics for a limited use case that doesn't need to be interoperable, and actually are the preferred means of doing small use cases in which you have no intention of joining them up to other things. My preferred, and I'm happy to be corrected by folks who disagree, but my preferred approach from an RDF perspective, because of the paradigm shift that I'm always advocating, is favor interoperability, therefore favor things like RDF that adopt open standards that learn from the lessons that have been hard won by experts over many years and deliberately make it more interoperable from the beginning.
Yeah.
Is that fair?
That is very fair. I don't know if you were here for the talk yesterday where we spoke about one graph. Did you see that? Yeah, I think that was one of the examples there, though, is where the query language for Cypher is actually a better one to use in that particular case. So
yes,
there are times when, obviously, yeah, each tool for its purpose, I guess. Good question, thank you. Anybody else would like to ask a question?
Great questions.
I think it's time to hand over then. Should we have a little break for you, Bran? Would you like a little few minutes to set up?
I just need 30 more seconds to copy something, and I'm good.
Oh, fabulous. Yeah.
Hello? Oh.
Hello.
Hello.
So the question is, if we have two systems and both are using different ontologies, how is that solved? Like, what is the approach?
Ooh.
Well, two systems may be using different ontologies, but if they are interoperating, then there must be something that joins them together. Those two different ontologies could be designed separately, they could be designed together. It doesn't really matter. What you want the ontology to be is to describe everything that you care about. In many ways, actually, if it's all part of the same solution, you don't really have two ontologies because they kind of go together to be one. And then you may have different data sets that are coming in to populate them from different places, but in the end, you want to treat it as your knowledge graph as an entirety, not really as silos wherever possible.
And, you know, I mean, I don't know if this will help, but at the beginning, when we were talking about SQL databases, of course, there are time series databases. There are all sorts of, you know, the document databases, there are graph databases. What I love about using an ontology is the ability to integrate what they call heterogeneous data sets that are in totally different formats. And actually, a graph database or an LPG can be one of those sources, and your ontology can map across to all of those to be able to make them far more interoperable as a result of having designed that. So you saw that Charlie showed different sources. We didn't go through the tab in detail, but you can connect to multiple sources and pull that information in as if it's one in exactly that way. So it's a great harmonizing kind of capability as a result of this, even if there are different graphs that you're sort of putting in. Is that fair to say?
Yeah.
Yep. Great, thank you.
Awesome. If there are any other questions, feel free to pop in, but if not, we can also have them at the end. We'll have some time. And the guys are here. You don't have to stand on stage if you want to sit, but you're absolutely welcome to be here. And I hope you guys will keep pitching in, because I'll be speaking about data products. And I'm pretty sure that I'll butcher something a bit. So, and why do I say this? Because the guys have been obviously very hard at work at the Enterprise Knowledge Graph Foundation and associated experts who are building this on basically standard, the data product standard on the ontology. Can we get yes, thank you. So going back to why we're all doing this, so back to our story that we're playing is, we have a car dealership. We all now did an exercise of taking some data from a car dealership database. We made it a graph. We connected it with an ontology in Graph.Build. You had a chance to play around with that ontology. You can still play around with it. And essentially, once you do that, you map it out once, right? And it's done. And from that moment on, you can have that stream of information whenever new cars pop up. Basically flow into that data product. Now, assume that we took the data that you did and we just added it into an OriginTrail node. So this will be one OriginTrail node implementing a data product, and we'll have another one that is somewhere on the other side of the world, which is in DMV's custody. We don't have access to it because it's DMV's, but there's some other data there, and we will now demonstrate how through the DKG these things communicate. And I will be switching a little bit between the agent view, so the UI, which tries to hide all of the complexity under the hood, and between a little bit of the code, so you see actually what's going on. And so I'm winging it a little bit. We haven't done this before, but at the end, we're gonna also, it's pretty much very soon, we're gonna see, because we have 20 more minutes, we're gonna see also what happens under the hood if I ask my agent that lives co-located with this data product to purchase some data from the DMV data product. But I wouldn't be me if I wouldn't just go a little bit deeper into what this looks like. So remember that architecture we saw yesterday? So I think sometimes we should remind ourselves, what does this mean? Like essentially, if you were setting up a node today or building a plugin today during the workshops, basically you've set up one of these. But through this node engine, it's connected with others immediately. So these nodes know how to find each other. They're a network. And they're specifically a peer-to-peer network, which means they don't have a central server hub, something that they need to speak to. There's no, it's not a hub and spoke model. It's a basically peer-to-peer network model. So when you spawn a node and connects to one of the networks, either the testnet or the mainnet, as we saw today, it's going to connect to one of these networks. Now, to give that also just enough of clarity, the mainnet is where you want to build production systems. That's where all of the components have been built. Every layer that we talked about, the trust layer, the knowledge layer, are deployed for production. That's where people run those core nodes at high availability. So basically, the best system you can get is the mainnet, and that's what you want to use. That's what enterprises use. But when you're building, when you're like playing around, developing things, you want to use the testnet because it doesn't cost you anything, and it kind of lets you hack it around. But because other people are hacking on it as well, you might notice that sometimes, let's say, so you publish something to the testnet, and a year later it's no longer there. Well, because people are destroying their nodes and putting them up again, and there's a lot of, so the testnet is not designed to preserve the test graph as much as the mainnet is designed, and that really comes from that economic aspect. So the incentives on the DKG mainnet are there to help to motivate basically people to run their nodes at the best they can. And they're motivated by the fees that come into the network. There's an economic benefit. If your node is not running at the highest health, as we call it, and I'll show that in a second, you will be losing out on rewards. So it's really a competition by people running core nodes to make their nodes the most powerful, the most healthy. And on the mainnet, that is like an active job. Like people have to work on this. It's not just, I deploy some server and forget about it. Because if you do that, you're not going to really do much. It's probably going to cost you more than it earns for you. But so basically, the point of this slide was that another way in OriginTrail world, these data products look like this, and they're just networked, and there can be many of them, so they know about each other. But now that I touched the mainnet, I just want to show you something. This is one of the UIs in the DKG, so this is the staking UI, and here you can see the list of nodes on the DKG, and these nodes have certain properties like a node power and node health, as you can see it here. For example, this node has maximum power of 100 and very close to 100 in terms of health, but there are certain, like for example, this node for some reason has 45, and this is a metric that is real time. So this could mean that in the last couple of hours, this node was, let's say, being updated. It was maybe offline for like an hour. And that's also okay. It's not that this node is all of a sudden horrible or something. It's just, we need to maintain things sometimes from time to time, whoever runs the nodes. But basically, I'm not going to stick here a lot. The point here is that if a node has high power and high health, that's good for the network. But on testnet, there's no incentive for people to really do much of that. So what I'm trying to say is, whenever you want to do something on the DK, that's why you would like to use the mainnet. Moving to now actually looking at these data products. So I'm gonna show, and then you guys can try it afterwards. And now I wish I was mic'd up because it's easier. But anyhow. So I'm gonna hop on into this node, the node of the data product, and I think I should already have saved username, password. Well, no, the password changed, I guess. So I need to get that somewhere. It's in the Excel sheet, bravo. But do I have the Excel sheet now? Let me get it. Sheet, here it is. Okay, thank you for that assist. Should all be the same. So yeah, I think we changed the password while we were setting it up. Okay, there it is. So something popped up, I'm not sure, but demo gods are always against us. So basically, you've seen this before. And this is just like the agent interface, nothing special of this first data product. And let me just see if everything is working, because that error that popped up looks like no.
There's some code that got somehow left in the chat. Just go back to the Yeah, no, this should work.
What, logging me out again?
Yeah, now it's good.
Okay. Let's try it.
Not sure what happened.
I'm typing with one hand, which is weird. Okay. Okay, demo gods, we win. So we have the agent, the classic chat interface, and what we're gonna now try to do is we're gonna ask some questions about the cars in this data product. Now I have some questions noted down here that I know are interesting, and we built queries for. No, I'm good. I'll be. Okay, yeah, thanks. Thank you. You're a legend, man. So let's say, okay, we have a bunch of cars. So let's say, what is the most common car being sold? If we ask that question, I'm curious what happens. And what actually happened is there's a Sparkle query that was executed, and please, I'll take it. Yeah, I'm good. Thank you. Or that. Can that work? Because that would be perfect. Hello. Yes. Thank you so much. All right, so what happened here? It looks like ChatGPT gave us an answer, but it didn't. This was actually coming from the data product, and we see that currently the most common brand in this data product, this dealership, is Toyota. There's 141 of them. Next comes Audi and so forth. And this comes from the data that we were playing with in Graph.Build. And what actually we saw happened is we saw that there were basically, there was a MCP tool executed with a query under the hood. So there's a Sparkle query. I'll show basically what does it look like, but I'm going to just play around with a few more questions, which somehow I got lost here. Yes, please, go ahead.
Just to recap on what we said yesterday, do you remember we were talking about probabilistic and deterministic responses? And the probabilistic aspects of asking a question in natural language being turned into a Sparkle query. And the Sparkle query from then on is deterministic. It's going to be perfectly repeatable and accurate. So any kind of hallucinatory concerns are likely to result in a failed Sparkle query, not inaccurate data. And that really is a massive improvement. And it's a paradigm that the pure machine learning folk, bless them, don't get. Because the thing is, they're still trying to make a probabilistic system act as if it's deterministic without, Neuro Symbolic AI is taking the best of both of these things and recognizing that. And that's why I love that brain slides that you guys have, because our brains aren't all fact and logic and reasoning, because we would have no creativity and there would be no singing last night or writing of songs and all this kind of stuff. So true intelligence is multimodal. And so this is quantifiably accurate response that's deterministic and repeatable now.
That's a wonderful interjection. Thanks a lot, Ben. Please do more of that, because I work with this all the time. I kind of assume that it's known, but it's not really. And that's such a great point. And I'll actually show these Sparkle queries under the hood. But basically, to hone in further on that point, let's ask another question. What is the best car in terms of price per mileage? Again, not something an LLM can guess its way into. And actually, it needs to retrieve that from the data product as well. So there's a query, again, that happened here. And we get, again, Neuro Symbolic reasoning says that Audi A4, for the price and the mileage, one of them here, is the best one. As you can see, 0.17 cents turns out per mile. So if that's a query that you would normally ask. And then let's say if we want to say something like, what car model has had most accidents? Again, what's going to happen is we're going to see a query that will basically execute on the graph under the hood. And you can see another MCP tool, so I'm going to show you how that works. And it says that, oh, I didn't realize a Mercedes-Benz C-Class. This is not real data, right? Yeah.
It is very much not real data. It's synthetic, and it was created by a GPT for us.
Yeah, of course. Oh, of course. So yeah, what we see here is average accidents, vehicle count, things like that. Good luck trying to do that query just with an LM. And so basically the data is so rich that you have to do certain traversals sometimes in the graph in order to be even able to make some conclusions like this. How does this look just under the hood? I should be able to, yes, to show. So you guys have been seeing the plugins. I'm going to zoom in a bit. So on the left, you see a DKG node project, and you see all of the folders and the code inside. And if you participated in workshop number 3, when we were building custom features into the agents, you were creating a package. That package is basically an NPM package. And in this case, we have a plugin DMV. So there's a bunch of other ones that come together with the node. But I won't stick here too much. I just wanted to show one example of how you could do it. So you could basically create a function called search for car. And that function would basically be in some way using a Sparkle query. So here's a way where if you really want to write the query yourself, this is how you could do it. You could also let the LLM generate the query, which is not a bad idea. But in this case, I wanted to show like how would this look like, because all day we've been speaking about Sparkle, and I don't think we've seen many queries. So let's look at least at one. And this query looks a lot like SQL. So we're going to select the vehicle, VIN number, color, these things, and then there's a certain where clause where the graph has the vehicle as type of vehicle and identification number. And I know the longer I speak about it, it's becoming more boring. so I will quit here. But basically my point being is that you can make a query or a query template like this, just like you kind of sometimes probably used to with SQL. You can still do that if you really want to go fully deterministic, and then you can execute that query on the DKG. So this is how you would call what is called the DKG client inside of the node. And so DKG client.graph.query just allows you to send a Sparkle query, and that query will execute on the graph underneath. And then you can do all kinds of things. We have also other queries here. I just wanted to jump in and show you that. And those are wrapped inside of the MCP tools. So these are helpers. But if we go here and we take a look at in the actual DKG plugin, you will see that there's either an API or an MCP tool registered, and this is the one I called. So here you give the description to the LLM, hey, this is what that tool does, and then you, where it is here, you call the actual function, search for car, see. So I know I might be running a little bit through it, but there's 12 minutes, I want to focus on something else. So this should connect with one of the previous workshops if you manage to follow it. But ultimately, what basically we've done here is, what I'm trying to say, it's nothing special. We wrote a few queries. From what I've shown so far, it's a couple of graph queries and just wrapping them in MCP tools. So nothing revolutionary, just simple, what we're used to type of programming, and then you can do all kinds of different things with it. Now, I want to move to the next point. So we got a bunch of information, and now let's say we want to buy a car. So the next question I'm going to ask is, I want to buy a car. I want to I want to buy a car, and I'm going to search, what did you recommend I search? Deep blue something, SUV. Search for, let's say, deep blue SUVs. Deep sea blue, okay. Yeah, I remember that. That one I'm sure works, okay. Let's see if that's gonna work. Okay, it works. It searches for available cars. Again, it has a tool built for this. And this is cool if you really want to have a number of deterministic executions. You can just build tools with very precise queries. All right, and it tells me here's a couple of deep sea blue SUVs, BMW, Audio 4, and so forth. And basically, we've seen this query already. This is coming from the same data. Now, let's do the DMV fetch. So we're going to do a query like this. Get me more details about this car, these cars. Grab the data from the DMV data product. And if everything goes right, it's going to contact the official DMV node, well, official in our world, in this workshop. And actually what's interesting, the query happens very fast. So it sent some VIN numbers and the query came back quite quickly. What's slow, why it's thinking is actually the LLM. So you can even turn off the LLM and use it without it. But because we want this to look nice for, obviously, people who are looking at the screen, we do it like this. Okay, so now let's dig a little bit deeper into what it says. BMW X5 with this VIN number has mileage 23,000 something, but reported was 10,000. So that is the difference between DMV and the data product that we were querying in the beginning. So it actually indicates a discrepancy. The official mileage is significantly higher than what was reported. This may indicate that the odometer has been tampered with. Always be cautious, and so on and so forth. And we, coming from Serbia and the Balkans, this happens a lot. so you really want to be careful. Everybody's selling these 20-year-old cards with like 50,000 kilometers on them. It's incredible. But yeah, so this is an example where we got this data connected from two places. And actually, the other results seem okay. Now, it's all magical. We got the answer. It looks so simple. But what happened under the hood? So let's go there. I'm going to try and show you an actual transaction that happened on the blockchain. I just need to see where I wrote it down. So, okay, this one. So again, we're going to go to a testnet. And then this testnet is, let me see, did it happen? Yeah, it did. So maybe I zoom in a bit. So if you've never seen this before, this is a blockchain explorer. In 30 seconds, it allows you to view all the transactions that happened on a blockchain. In this case, we're using the base testnet, and I'll explain why. But for now, just consider it as a blockchain. And we're looking at the address of a wallet. If you remember today, I spoke about a wallet, basically a wallet being something that contains owns tokens. Those tokens can be monetary, fungible, as we call them. And in this case, you can see on the right here, it's USDC. So it's a version of a crypto version of the US dollar. But it can also be non-fungible tokens. For example, it could be knowledge assets. So this address is basically kind of like an account number in the bank. And in this case, this is the account number of the DMV data product. Now, when you look at it like this on the blockchain, it doesn't say so. And that's also the point. Like, we don't want to have all of the transactions super incredibly richly visible to anybody. But these nodes, if they want to transact, they need to obviously have some sort of addresses. So it's somewhat anonymized, privacy preserving, and a node or data product can have many of these addresses. It can generate one-time addresses if there's a need for like super high privacy. But as you can see, and of course we've been testing this a little bit throughout the day just to make sure that everything works for the demo. You can see a transaction here. I'm going to open one transaction. And this transaction says basically that we paid 0.0001 US dollars, so 10 to the minus 4, to purchase the necessary data to give us that answer. And this happened, well, what was it, 3 minutes ago, 4 minutes ago? So when I executed that question, this happened under the hood. And this demonstrates the usage of this new emerging standard called X402. Why is X402 exciting? Why is it called X402? You know how just using the internet, you run into these 404 codes like page not found or 500 server error. Well, it turns out when they were specifying HTTP, they specified the code 402 payment required. And it was never built because we didn't have internet native money and nobody really cared about it. So we had like the likes of PayPal and the Stripe, the big ones. They basically build products Web 2 style that do this. What's really interesting is, and I only found that out recently, if you're using Stripe, they charge some insane amount, like 30 cents per transaction. So imagine us wanting to build some form of system like this that pays 10 to the minus 4 US dollar, and they charge you 30 cents on top. You had a question? Yeah.
Yes, I do. I was just wondering if you could at all incorporate error code 412 as well, and if you could let the audience know what that is, if you know what that is, Branimir. 412.
412?
Do you know what that one is? Again, it was little used in the industry and the web over the years. Do you not?
Not on top of my mind. Okay. Remind me.
All right. Well, you could possibly bring up a tab and show people what you're supposed to use error code 412 for from the HTTP code.
Precondition failed. Client errors. Okay.
I thought it was. Is it 412? 418. Sorry, 418. You're right. That one was quite heavily used. 418 is the one I'm thinking of.
That's a good one. We need to implement that. Bring me some tea. But yeah. The HTTP equivalent being rickrolled in the middle of it.
You're up to something, Charles Ivie. Just one of the things that to add when we're talking about this, I get very excited about this because when I'm thinking in enterprises, one of the most dysfunctional aspects associated with trying to manage data in large enterprises is that the department that creates the data for a particular purpose in a particular system thinks it's fine because they control the system that created it, and if it wasn't fine for their purposes, they'd fix it, right? However, often downstream, that data is being used by multiple parties, say 30 different parties downstream within an organization, and they might need it in different formats. They might say it's not fit for their purpose, etc. And often we teach people how to communicate their requirements back to the source, to be able to say, actually, we need this in a different format. Now, that's all well and good, but if there isn't the incentive, you remember Chris Reining's fabulous phrase, I always borrow, from Charles Munger originally, which is, you show me the incentive, I'll show you the outcome, or I'll tell you the outcome. There is no incentive for the producer of that data, often in most enterprises, to make it fit for purpose for the consumers, because there is no transaction there. Often they're not even being told what the requirements are, so we at least help that. But the ability to be able to charge a small amount of money for the upkeep of that data by the consumers in the organization, enable them to be incentivized, and in exactly the same way that, of course, is baked into OriginTrail's decentralized knowledge graph, creates a network of incentives for us to improve things iteratively. And this is one of the many mechanisms that Bran has baked in, because his vision is so, and the team's vision is so phenomenal, enables that value transfer to happen and the incentives to align with an organization. It makes my job a lot easier when I'm sort of trying to create mechanisms within large enterprises for the consumers to plead with the producers to try and fix it, when there is no mechanism for them to be able to incentivize them to do that. So I just wanted to add that, because that is a major problem in almost every large enterprise, the consumer to produce a contract, and this helps solve that. So hope that's helpful again.
Absolutely, thank you. Thank you for providing very important context from your experience, because a lot of us who haven't touched these types of problems maybe not completely aware of how powerful this is. And it's also very flexible. So it doesn't have to be US dollars, as I showed you. It can be any token, it can be the TRAD token, it can be a token you make, whatever. It's just a protocol that basically says, send me this many tokens, and I'll send you back the data. And that's the X402, and as you can see, it operates together seamlessly with the DKG node. And seamlessly meaning I was just chatting. So it, in a way, what we really want to see here is imagine a ChatGPT user using ChatGPT, but instead of getting pure ChatGPT answers, they have the same user experience in ChatGPT, but the answers are read from the DKG, and all of the economic activity happens on those rails, and they don't even have to know, which is great because we can get basically, as you guys showed in the beginning of the presentation, what was it? 400% better results in retrieval and basically answering when you do what? 10 minutes of semantic modeling? 10 minutes. It's incredible. So imagine as we grow the graph and we get into hundreds of billions of knowledge assets, it will be a no-brainer to include this knowledge base into your any AI chatbot type flow or anything else. We're literally touching the end of time, but I just want to show one more thing. You don't have to have this be under the hood. You can also make the user conscious. So the way that looks like, oh, no, that's not it. This is, by the way, the data product. That's the JSON you guys showed previously. Yeah, I'm going to hop into that, but this is the previous one. So just so we know we're actually looking at the data product. So this, if you go to the DPROD /DPROD, it's going to return this. You can also ask, what can I ask? Oh, I totally messed this up. How do I ask to give me this data from the chatbot? Something like, tell me
more about the DPROD, something like that.
Yeah, so let's run that. But anyways, because we're out of time and we need to do the last workshop, yeah, basically it's gonna. So there's a way you can access this that you don't have to look at that JSON, even with pretty printed, it looks horrible. So yeah, it's gonna tell you, okay, this is the output port and everything. So basically, we can do it all conversationally, Neuro Symbolic. But let's say there's a pop-up. The user maybe runs into a question: do you want to pay to get a better answer? And so it just doesn't happen under the hood. It's great if it can happen under the hood, but sometimes we want to let the user do it. So this is a way. This will pop up actually. So I just had it open in the browser because I didn't want to mess something up. But basically, this is what it says: access to premium content. And actually, you know what? I should try it. Let's see if I can buy it. So I'm connecting a wallet. This is a wallet, one of the wallets that I like. It's called Rabbi Wallet. That doesn't matter much, but it's really cool. And I got this address here, which actually has a little bit of USDC to pay. So I should be able to connect it here. It's going to ask me if I want to send this transaction. It's even going to alert me if I'm sure to do this, but I am. And again, I'm doing this on testnet. I connected the wallet, and now it's going to say, all right, you want to pay? I'm going to go ahead and pay, which basically means I'm signing a transaction with my wallet. And once I do so, takes a bit to mine this transaction. There you go. There's the data. I just got it in the old school way, not in the new nice chatbot style way. All right, we are over time. We have one more session. I'm going to just, I guess, open it up for one last question. If anybody has any. But it's okay if you don't, because I understand we've been speaking for a while. But if there's a question, please raise your hand. A mic will come your way. There's a question over there. Can we send a microphone, please?
Test. Okay. So my question is, until now, for any kind of data source that we have on basically the internet, it's been mostly either subscription-based or pay-per access, but it's never been truly on demand. It's usually you get a quota or you get a limit of how much data you can access, and you need to pay in bulk for it, even if you don't need the whole data. Do you see this progressing? Because I see it that way, so I'm interested what you think, that we're going to move to a model where not only is it agentic, but it's also everything is on demand. Like I don't ever need to overpay for data. I only use what I want and when I want it? Or do you think we're still gonna struggle with the major corporations wanting to actually have you pay in bulk even if you don't use the whole, even if you don't utilize the full amount of what you pay for?
That's a very good question. I couldn't say I know what's going to happen exactly in the future, but I think this is going to proliferate a lot because it's very useful. And one of the reasons I started speaking about, but somehow I got sidetracked, is because it actually all of a sudden enables that you move away from the subscription model. With Stripe, for example, you kind of have to make a subscription because you have to eat up that 30 cents per transaction. So you want to make it one transaction of, I don't know, $10, so that the 30 cents is not that bad. But if you have like 30 cents for every transaction, that doesn't work. So it probably unlocks a lot of this. That's how it makes sense, I guess. But there's so many different business models, and I guess enterprises might, they tend to be slow a bit, so it might be that they don't pick this up as much. But I'm pretty sure that the open source community, and I'm very excited that this also doesn't apply just to the crypto community, because you can do X402 in other ways as well. I think we're gonna drive this one, and it's gonna go really fast. So yeah, that's as far as in the future I can look at, but I think it's gonna pick up vastly. So
we were going to ask if we could take a photo with all of your smiling faces.
Oh, yes.
So if we get Charlie here and everybody, yeah, excellent. Love it, Amos. We get everybody in. Sorry, my arm is not long enough. Hey. So thanks everybody for listening to us. We've really enjoyed spending time with you, and hopefully it's been useful. Thank you.